So if I want to find the value of this limit, it would probably be helpful if I had a picture. You guys practice using the graph to find your limits last night. And that's kind of helpful to have that visual. When we graph piecewise functions, what we did is made a t-chart for each piece. So if I'm looking at the first one, it's 1 if x does not equal 0. Okay, so you can put in anything. We would have to put in the 0, but what would be true at the 0? What kind of simple that would be? Open. And no matter what, we get out 1. So negative 1, 1, 0, 1 is an open circle. 1, 1 is closed. Can you tell what this looks like? Horizontal line with just a hole. Okay, the second piece, 0 if x equals 0, how do we graph that? What's the only x value you could plug in? 0. And what do you get out? It's just a single point. So what we have is a line with a hole in the middle and a point elsewhere. So the limit as x approaches 0. This is a two-sided, so they have to match as you're coming in from both the left and the right. Does it go to a single value? What is it? No. Remember, limit, doesn't matter what happens at the point, it matters as you're getting close to it. So as I come in from the left, what y value am I approaching? 1. As I come in from the right, what y value am I approaching? 1. So my limit, as x approaches 0 of this function is 1. Doesn't matter where the point is, it matters if you're traveling on the graph, where are you going to end up? We skipped example 3 also, right? Let's look at this one. I want the limit as x approaches 0 of this function is what? So what do I need to do? Graph, yep. We need our t-chart to get our graph. Okay, and I've kind of already broken it up for you. So my function was x divided by the absolute value of x. But what it turns into is just 1 if x is greater than 0, and negative 1 if x is less than 0. Why can't x equal 0? Yeah, can we do 0 divided by 0? No. Okay, so I've already simplified it into this. So this is what we need to graph. 1 if x is greater than 0. Okay, so you put in 0, it will be open. You have things larger than that. What am I getting out every time? So 0, 1 is open. 1, 1, 2, 1. So this looks like that. The other piece, we also have to start with 0, and it would also be open. And then we do things less than that. And what do I get out every time? So I'm asking you for the two-sided limit as we approach 0. So as I come in from the left, what is it approaching as I come in from the left? Negative 1. As I come in from the right, it's going to positive 1. We kind of saw in our homework last night that time when the limit does not exist, it's when you have a break in your graph and those pieces don't match up. So overall, this limit does not exist. We have one-sided limits, but we don't have a two-sided because the two sides do not meet up. Is that think those were the only two examples I skipped yesterday, is that right? So now we're going to talk about infinite limits. All problems we've looked at so far, we've either gotten the limit to equal a number or we have a case where it does not exist. But it is possible for the limit to equal infinity. So the limit as x approaches a of a function equals infinity just means as you're approaching that number, the y value is getting larger and larger. How could that happen on a graph? As we're going into a certain x value, the y is just going up and up and up. When do you see something like that? Yes, asymptotes, vertical asymptotes. You remember like 1 over x. When we graph that, we had something that looks like this. So as it approached 0, it's going higher and higher and higher. What happens if you approach 0 from the left on this? So it can equal a positive or a negative infinity. And the situation where we usually see this is with vertical asymptotes. I have a lot of pictures just illustrating a lot of different scenarios. So we could have a two-sided limit. Here we have a vertical asymptote, but both sides are going up, so the overall limit would go to infinity. Here both sides are going down, so the overall limit would be negative infinity. Or we could have cases where it only exists on one side, so the function stops at that point. So this one, we would have a limit as we approach a from the left, but there would not be a limit as we approach a from the right, because the graph doesn't exist over there. This one has a limit from the right, but not from the left, because there is no portion of the graph on the left. So just illustrating a few different situations that we could encounter here. So let's try some.
If there's a vertical asymptote going from both sides, they're both going up, they both no longer touch that point.
Correct.
So how can we say that like it's going to infinity? Because then technically like there's a break.
But
Or the break
remember,
only on the y.
we don't care what happens at the point, just as we get close to it. So if graph looked like this. So let's say we had a vertical asymptote at 2. And our graph like this. Okay, so if I ask you the limit as x approaches 2. A limit doesn't care what happens at 2. You're correct, at 2 the function doesn't exist. But the limit is just if you are traveling on this function getting closer and closer and closer to 2, what is your y value getting closer and closer and closer to? And the y is just getting larger and larger and larger. If we looked at the table of values, we would have things like put in 2.1, we might get 100. 2.01 might give us 1,000. 2.001 might go to 10,000. So our x's are getting closer to 2, and the y is just getting larger and larger and larger. So we don't care at the point, just as we get close to it. Did that answer your question? Okay. Any other questions? So let's look at this one. Okay, I'm asking for the limit as we approach 0 from the right and as we approach 0 from the left of the square root of x. So I probably need a graph to help me out here. You might remember what a square root looks like. If not, we can figure it out. Can you plug in negatives? No, that's going to give us an imaginary. Can I put in 0? Square root of 0 is? I put in 1. Square root of 1 is? Give me another number we can take square root of. 4 would give me a 2. 9 would give me 3. So let's try this. 0, 0. there's my square root graph. So the limit as we approach 0 from the right. So as we're traveling on this graph, getting closer to 0 from the right-hand side, what y value is this approaching? 0. What would be the limit as we approach 0 from the left? There's nothing on the left-hand side, so it does not exist. But if I asked you for the overall limit as you approach 0, that means if you come in from both sides at once, can we come in from both sides at once? No? So what do we put? Does not exist. Alright. Let's try this. We're looking at the limit as we approach 3 from both the left and the right. What's going to happen at 3? Remember from college algebra, when the denominator is 0, that's when we get the vertical asymptotes. If you limit, go ahead and graph this on your calculator. 2x over x minus 3. Also, just as a side note, we're kind of using the graphs to help us now. You could still do these on T-charts as well. If you only are doing a left or right, you would only have to put in values bigger or smaller. Because this is how clouds are turning. If you go up, highlight them and turn, see this one is they're on. Alright. So what's your graph look like? Something like this on that side and like this on the other side. Okay, so the limit as we approach 3 from the right. So if you look at your graph as you're coming into 3 from the right hand side, what's it going to? The limit as we approach 3 from the left. That one's going to make the overall limit as we approach 3. What would it be? Does not exist, yeah. Oh, you just need to reset your window. If you go to Zoom 6, it will reset.
Thank you.
Yeah. You need to reset your window. You're just zoomed in. Another way we could get this is by doing that T-chart, like we've done quite a few times. So for the right-hand one, you do things bigger than 3. And we're plugging them into 2x over x minus 3. Let's try it and see what we get. 3.1, I got 62. Oh, 1, I got 602. 3.001, I get 6,002. So, are these y's approaching any number in particular? No, but we can see they're getting larger and larger and larger, so this is approaching infinity, which is what we did. If we want to do from the left, you have to put in things smaller than 3. So if we plug those in. Negative 58. Negative 598. Negative 5,998. So what are those approaching? So really we have two options for finding these now. We can make the t-charts, or we could look at a graph. Why don't you guys try the next two examples and see if you can figure those out. You can use okay, I'm walking around seeing different options. Some of you use the t-chart to draw the graph. Some of you use your graphing calculator to draw the graph. Some of you did the t-chart to find the value that it was approaching. And all of those are good options, and you will work. When you looked at the graph, probably the only thing that might have got you, if you're just staring at the calculator, it's kind of hard to know exactly what this point was. But if you plugged in a 0, you got a 4, and then it kind of looked like that, didn't it? If you made the t-chart, we need things that are approaching 0, but only from the right, so only things that are bigger than 0. So you don't have to make 2 of them, you really only have to do 1 of them, the ones with the positives that are in 0. And when you plug those in, you got, it's like 4 point, and you got pretty much the same thing every time. If we were able to see more digits on the calculator, we would have noticed a difference, but the difference is so small that we're really not seeing it yet. So if we look at this, what's it approaching? 4. If we look at our graph, as we are coming in from the right, traveling on this line, what's our y value approaching? 4. So either way, we should get 4. Right. Is that one okay? The second one. If you try to do the t-chart and plug in, we need things bigger than 3, so 3.1, 3.01, 3.001. What are you getting if you put those in your calculator? Errors. Okay, let's figure out what this looks like. If you graphed it, what we get is if you put in negative 3, you get 0. If you put in 0, we get 3. If you put in positive 3, you get 0. We have just a semicircle. Calculator draws that much better than I did right there. So when I look at this, if I'm approaching from the right, I'm coming in from this direction, there's nothing here. We got errors because the graph doesn't exist over there. It's outside of the domain. So what's my limit? Does not exist because we can't travel in from the right. Now what if I'd set the limit as you approach 3 from the left? What would that have been? If we were coming in from the left-hand side, it would be going to 0. So we have a left-hand limit there, but not a right-hand. Okay. Final question. Just because trig functions come up periodically, so I want to start throwing them in every now and then so we don't forget too much. Vertical asymptotes, those are the places where we get those limits as it's going to positive or negative infinity, so they are important. when I talked about tangent, can you figure out where do we have those vertical asymptotes on tangent?
Or is radical 2 to the negative x?
Not quite.
Or 1?
You're thinking of what tangents, like the y guys. I'm looking for an x. How do we find tangent? Y over x, or sine over cosine. So we're going to get an asymptote when cosine is equal to 0, right? So think about your handshake or your unit circle. Cosine is the x. When is x 0?
90 and 270.
So that is pi over 2 and 3 pi over 2. So those would be the two times between 0 and 2 pi when tangent would be undefined. And then we know everything coterminal to those. It would be that way as well. So basically it's every time you go around the circle and hit the pi over 2 or 3 pi over 2, tangent would have a vertical asymptote. Okay, so I am done with this section. The homework, so it's a little bit longer than some of the other ones, and it is out of the book. I am going to give you class time tomorrow as well. Hold on, I do think I already changed for this though. Alright, I'm going to take off problem 45. So tomorrow